Absolutely, there is life elsewhere, and almost certainly intelligent life. It has to be. The odds are just overwhelming.
NASA's Voyager probes were launched into space.
Why have we not heard from the aliens?
Aliens on Earth, it would probably be me. Where are the aliens? Maybe they're among us, I don't know.
Initiating a historic interstellar trip that demonstrated our ability to monitor not only Earth, but also the solar system and beyond. These amazing spacecraft are still giving scientists new information about space 45 years later. These amazing probes continue to lead space exploration even with a memory capacity 3 million times less than a typical smartphone and an operating speed 38,000 times slower than a 5G internet connection. However, in a startling turn of events, the Voyagers have made an impossibly difficult discovery. What do they do at this moment? What will be the next encounter for the Voyager spacecraft? Let's investigate. Voyager 1 was launched into space on September 5, 1977, from Cape Canaveral, Florida, using a Titan IIE/Centaur rocket. This was the beginning of an incredible adventure. 13 days later, on August 20, 1977, Voyager 2 made the same journey into space, starting a parallel odyssey. Their main goal was to investigate Jupiter, Saturn, and other gas giants in our solar system, as well as their orbiting moons. But these daring adventurers went much beyond what they had planned to do, for they were setting out to explore the furthest limits of our heavenly neighborhood. Throughout their historic journey, Voyager 1 and Voyager 2 broke a number of records, lasting longer than any other spacecraft and venturing farther from Earth than any man-made object. They are the first artifacts made by humans to have really reached interstellar space. Their voyage into interstellar space, outside the solar system and into the unknown regions of the galaxy, has yielded priceless information for astronomers. Even after traveling more than 12 billion miles from Earth, these trailblazing interstellar probes never cease to astound physicists with their discoveries. One of those discoveries that scientists could never have predicted is the recent impossible discovery, which we shall look at in more depth later. The Voyager twin probes have accomplished some truly amazing feats. Their groundbreaking discoveries of the moons of Jupiter and Saturn, made more than 40 years ago, shocked scientists and disproved preconceived notions about these far-off planets. During its voyage, Voyager 2 in particular reached a number of noteworthy milestones. In 1986, it made history by becoming the first spacecraft to fly by Uranus. 3 years later, it made a flyby of Neptune. It is still the only spacecraft that has ever traveled along this route. NASA has taken a number of steps to increase the spacecraft's operating longevity as they continue their incredible journey. With an expected mission end date of 2030, non-essential parts and heaters have been shut off to preserve energy during the past 3 years, allowing them to function long into the upcoming decade. The conclusion of the Voyager missions is a bittersweet time for the scientists and engineers who have been a part of this incredible voyage since its beginning. Their commitment and diligence have allowed the project to be completed significantly more successfully than they had anticipated. Numerous scientific breakthroughs, insightful information, and the inspiration of future generations of scholars and space enthusiasts have all been made possible by the data that the Voyagers brought back. Ordinary spacecraft were not what Voyager 1 and Voyager 2 were. Their precise design called for them to be stable platforms, rotating at a rate that is over 15 times slower than a clock's hour hand. Because of its design, there was less visual blur as the spaceship was speeding through space and taking pictures and data. Even before they encountered the outer planets, their astounding imaging skills started to amaze scientists and the general public. While still several months away from Jupiter, the spacecraft began to transmit photographs of the planet. The gas giant's whirling clouds and recognizable Great Red Spot were seen in these early photos, which thrilled viewers at NASA's Jet Propulsion Laboratory. But the real catalyst for the Voyager's groundbreaking observations was the finding of active volcanoes on Jupiter's moon, Io. It was discovered that Io, a moon that is marginally bigger than Earth, is the solar system's most volcanically active body. The spacecraft's equipment validated the strange signals they picked up from Io with the help of the bright photographs they took. These photos showed a surface marked by the ejection of volcanic material, as well as tall volcanic plumes. Almost the whole territory of France has been covered by the eruption of Pelée, one of Io's most notable volcanoes, which occurred 30 times higher than Mount Everest. Over 33,000 photos of Jupiter and its moons were taken by the Voyager spacecraft, demonstrating both the beauty of the planet and the astounding variety of moonscapes in the Jovian system. Since their debut, the twin Voyagers have been making amazing discoveries, until the most recent impossibility of a discovery. The discovery that Jupiter had rings was among the most unexpected. Even though they were dim, these rings were a discovery that raised the gas giant's mystery. Furthermore, one of Jupiter's 53 known moons, Europa, was discovered by Voyager 2 to have an icy shell that was estimated to be more than 60 miles thick. These discoveries raised questions about earlier theories on the characteristics of these far-off celestial entities and motivated more research into the possibility that frozen moons could be habitable. The Voyagers were given a final kick of gravity when they left Jupiter, which helped them move in the direction of Saturn. They would never have been able to break free of the sun's gravitational pull and travel farther into space without this essential push. Soon after, Voyagers 1 and 2 parted ways, each pursuing uncharted territory. Voyager 1 passed near to Titan, Saturn's moon, which has a hazy, orange atmosphere. Scientists' curiosity about this moon's mysteries led to more research into its intricate chemistry. After that, Voyager 1 swung north and left the planet-planet system, starting its journey outside of our solar system. In contrast, Voyager 2 set off on a journey that would take it to the solar system's outermost planets. It increased the number of moons on Uranus to 10 by finding 10 of the planet's previously undiscovered moons during a historic flyby in 1986. Voyager 2 arrived at Neptune 3 years later, exposing the amazing characteristics of this far-off ice giant. Voyager 2 reported wind speeds of up to 1,000 miles per hour during its flyby with Neptune, which is the fastest wind ever measured on a planet in our solar system. With its close approach to Neptune's azure, methane-rich atmosphere, the spacecraft offered hitherto unheard-of insights on this far-off planet. It was discovered that Triton, the biggest moon of Neptune, is among the solar system's coldest locations, with surface temperatures falling as low as -391 degrees Fahrenheit, -235 degrees Celsius. Triton also had peculiarities, such as ice volcanoes that shot icy particles and nitrogen gas 5 miles into its thin atmosphere. Our knowledge of the variety and complexity of celestial bodies in our solar system, even in its most distant areas, has increased as a result of these findings. Astronomer Carl Sagan was one person who was instrumental in the missions going above and beyond their original objectives. As an imaging team member of the Voyager mission, he strongly supported taking one more round of pictures before the cameras on board both spacecraft were shut down. A farewell gift to humanity, these pictures would provide a last look at Earth from the far reaches of space. Sagan's perseverance was rewarded. Voyager 1 aimed its camera back toward the inner solar system on Valentine's Day, 1990, and took a set of 60 pictures. The most well-known of them, dubbed the pale blue dot, is nonetheless an enduring representation of our position in the universe. Captured at a staggering 3.8 billion miles away, this is the farthest photograph of Earth yet documented. In the expanse of space, Earth appears as a small, pale blue speck that is hardly noticeable. A story of incredible sturdiness and longevity, the Voyager mission reads like a comic book about space-age superheroes. And they are still out there, sending us important data from the farthest regions of our cosmic neighborhood, even after 40 years. Let's now discuss their antiquated 8-track cassette technology. Yes, you read correctly. The Voyager probes still utilize the 8-track records that were so popular in the 1970s. The fact that these reliable cassettes have endured over time is evidence of the mission's creators' brilliance. You might question, but why 8-track tapes? The concept of digital storage as we know it now was very new during those early space exploration days. Those 8-track tapes were a perfect fit for their needs as a dependable and robust data storage method. They resemble the cosmic age's unbreakable workhorses. Even more astounding is the fact that the information on these cassettes contains priceless scientific data about the outer planets, moons, and interstellar space rather than simply ordinary music. Yes, these cassettes are essential to unlocking some of the universe's most fundamental riddles. When considering durability, keep in mind that the Voyager spacecraft are subjected to high temperatures, space vacuum, and cosmic radiation. Still, these elderly adventurers continue to go. It's similar like sending your grandparents on an Arctic hike where they not only make it through, but flourish. Which tactics were employed to guarantee the Voyager mission's success? The gravity assist maneuvers approach was one that was crucial. They played a magnificent role in these fabled intergalactic journeys. Consider the daring Voyager 1 and Voyager 2 spacecraft, embarking on their bold mission to investigate the far corners of our solar system. They need more of an acceleration than their own propulsion systems could offer in order to reach these far-off locations and collect priceless data. This is when the use of gravity becomes relevant. It's similar to cosmic dance. Rather than depending only on their engines, these spacecraft engaged in a celestial dance with some of the largest planets in our solar system, slingshotting themselves forward due to their enormous gravitational attraction. By using this cunning move, they were able to save valuable fuel and increase their speed, which helped them reach more stops on their grand tour. Let's begin with the fundamentals. A gravitational slingshot, or gravity assist, works by giving the spaceship a portion of the momentum of a passing planet. Imagine Voyager 1 traveling toward Jupiter, a large gas giant with a commensurate gravitational force. Voyager 1 flew by Jupiter at precisely the appropriate angle and speed, a feat only the most brilliant minds at NASA's Jet Propulsion Laboratory could have accomplished. The spacecraft was pulled toward Jupiter by its gravitational pull, which increased its velocity. Voyager 1 received a cosmic boost that provided the necessary impetus. However, this move is an art. Voyager 1 might have experienced a cosmic disaster and gone off track if it had reached Jupiter at the incorrect angle or speed during the slingshot. The level of precision needed is astounding. Nonetheless, the engineers and scientists responsible for this cosmic ballet made several correct guesses. Voyager 1 and Voyager 2 underwent an amazing solar system journey thanks to these gravity aids. For example, Voyager 2 required gravitational aids from Saturn and Jupiter to reach Neptune and Uranus. The Grand Tour was made possible in large part by these celestial dances. Without these slingshots, the Voyager missions would not have been the same. Despite using gravity assist maneuvers to travel through space, the Voyager missions would have been nothing more than space fantasies if one important element had not been present: the Deep Space Network, DSN. Imagine it as our intergalactic phone connection, connecting us to our brave Voyager probes as they ventured into the vast unknown. Now, let's define the Deep Space Network precisely. While it's not as ostentatious as a spacecraft, it's just as important. The DSN is a global network of enormous radio antennas that are positioned all over the world, including in Australia, California, and Spain. These enormous dishes, which have diameters ranging from 26 to an incredible 70 meters, function as cosmic megaphones that let us speak with spacecraft that are orbiting other planets. Let us now discuss its involvement throughout the Voyager missions. With their instruments, cameras, and sensors, the Voyager probes served as our virtual eyes and ears in the expanse of space. We required a reliable communication mechanism, which is what the DSN provided, so we could interpret the information they sent back and provide them with new instructions. Imagine this. Voyager 1 transmits a message to Earth as it is traveling to the furthest regions of the solar system. The signal is feeble and moving at the speed of light. Through the vastness of space, its power diminishes. It's barely a murmur when it gets to Earth. However, the massive antennas of the DSN are ready to pick up that whisper. They latch onto the weak signal from Voyager and boost it so that scientists can use it for analysis. In addition to receiving signals, the DSN may also transmit commands. Missions like as Voyager, you see, are dynamic. Engineers and scientists have to make adjustments to their instruments, reroute the spaceship, or modify their plans. Through the DSN, they transmit these directives, and Voyager receives them by beaming them into space. The dialogue is bidirectional and takes place between Earth and the most distant human-made objects in space. The DSN's ability to run around the clock and never stop searching for those far-off signals is one of its amazing qualities. Maintaining communication with our spacecraft, even when they are billions of miles distant, is akin to maintaining a watchful eye on space. The Voyager missions serve as an example of the strength of creativity and teamwork. The DSN ensured that the spacecraft were never really alone as they set off on their amazing missions. It allowed humanity to go into interstellar space and investigate the outer planets by bridging the gap between our planet and the unknown.